at a glance, we are we kind of want to consider ourselves as a technology company where our core businesses is control, where it leads to like energy management, digital factories, industrial. But we also have other branches like other vision like healthcare. And we actually produce those wind turbines. Uh, we also produce generation, turbine, trains. If you don't know, smart building and campuses. Um, this is not oh, wrong way, but this is about Siemens. Like this today about smart building. What is smart building? I mean, IoT. You have data and collect data as you can collect and change your temperature or thermostat from the phone. You call it smart. So smartphone or smart device. But smart building should be more than that. Definition, put this in there because I want to just share about definition of smart building. Um, it's like is how we data for to make building more comfortable for user. Oh, sorry, I just got a message there. There's funky transition. Oh yeah, my bandwidth. So anyway, I hope everything's good now. Is it very choppy? All right, let me try different things.
This is my Apple. How about now? Is this better? Much louder? Okay, cool. All right, I'm just going to hold my microphone and talk like this for now then. Just make sure that I get my message pretty well. Like, all right. So how can smart building indoor quality, right? Indoor air qualities, right? No, I mean, it's all about Corona now. We know actually like there where you guys stand like 6 feet apart. We joke around in the office using something like that, like 6. You're not 6 feet, so get away from me. So not everybody's using masks. Will this be a new normal? This way, and we don't know. But we do is as an HVAC professional, always like this. I always refer to Ashley because Ashley already have a guideline for air ventilation. 62.1 is actually the true code in the US at least. I'm not quite sure in Canada similar, but under the code section for reduced airborne exposure, and there's they actually have a document right now on it right there. It's focusing on COVID and before. the thing is was specifically for hospital, but now they are making it say this. This is our recommendation, but there have the proper recommendation there for recommendation. First one is dilution, uh, and then optimization. It's like filtration and use UV. They don't really recommend bipolar ionization yet. UV has been used in healthcare for a while. But then comes the fire, right? So how can you, on the right-hand side is how it all looks lately. This is like still in the last like week or so. The quality PM25 is about 200 right now, and it's kind of because if you look at online data, um, the air quality in Seattle and Portland area worse in the world. Usually way better, but right of the world. With COVID, you outside air, you have fires. What will it do, right? It's a double whammy that like we have all this. We need to increase ventilation. What will happen to our filter? Can we do? I mean, this stuff will equal increase in energy. So for doing that, as we refer to, I like data, things like that. This is on regard to the first. I want to introduce you to some type of K, like half. So how much percentage of the virus is actually active within a period of time? An exponential decay is actually great because, I mean, you know, to get to it takes significantly less time than get to zero. That's the good part, but the part is, where is the safe zone? What is the safe zone that we need to achieve on that? And this is the data with corona and temperature. Our data from the lab that they get decay of the virus with temperature, and it's interesting because I mean you can reach half around like 70 degrees to 80 degrees, but if you want to kill it, you can go up to like 100 degrees. These are Fahrenheit, not Celsius. So it will, I mean, can use this table to optimize it. All right, then how do we control in a room typically? I mean, there's two, right? So like usually temperature and humidity, right? So how does COVID like get transferred, right? How can you get infected? Usually through droplets, through flying particles of virus. Someone either asymptomatic, have some a cough or a things from body. I mean, it's yucky, but that's how it is. But there is actually an ideal humidity that we can to keep for the build that the building is operates at a certain way That's very ideal, which is between 40 to 60%. So this is actually true with most airborne, but I know flu is not corona, but the way it transmits is kind of the same. So we have this transmission rate that these are tests, the data, and where if you maintain between 40 to 60 relative humidity in the building, the transmission percentage rate decreased significantly, especially in that 50% zone. All right, from that data, so we can tell something that, hey, I mean, now we know where we need to be, right? And how we optimize it. But the other question is like, what will we do if there is somebody come in with COVID? What can we deactivate? We will do all this manual cleaning and scrub everything. But how can we make sure it's not transported through our HVAC? So we've been experimenting with one called defense mode with the temperature. So we cannot really control who's coming into the building, right? We can control that they don't have a fever. We can control we don't have, but I mean, we cannot really control the like even know whether they actually have COVID or not. So with this, we have we can do it with building. We can have a button that say when there's a sick person show up within a certain hours, we go on the activation defense mode that will increase the temperatures, put the humidity, shit that will save energy. But anyway, as you can tell, all that will increase energy consumption. But I mean, I'm going to show you of what I've been playing with in the past year or so, testing what we call machine learning. And I believe this is one of the, this will be the future for HVAC. We call it actually dynamic VAV operation. And building change over time. We have occupancy come and go. And there's all this priority change, right? So there's hot, cold, facilities manager, you all know that. But one thing that typically at the last that I want to do at building is grades, right? Control. I mean, they always said building owner says like, well, your update control is very expensive. How do we do that? But just one, and a lot of things run on a variable air volume system, and they have boxes directly control the temperatures in the room, right? So in a modern building, you have VAV boxes and you have a air handler. The air handler pushes the VAV boxes. The VAV boxes have a damper and put the air in based on the temperature or humidity set point to the building. It's a basic two question and two set points variable. We especially don't ask is like, what's the temperature? That's translate to how much air and what's the how much conditioning we need to do. And probably a refresher for SKU. This is kind of how the VA actually Just to let you know, these are simplified model, right? This is not like there are VAVs that have, fan and all this, or cooling and heating. But this one, a lot of like things like 70% of the building I've been in have a standard damper, a reheat coil. And that's how you control the airflow. So when the temperature in the room gets hot, and temperature's like, hey, I'm 2 degrees above set point here, and they start to open the damper and push the cold air in. And when the rooms say, hey, I'm too cold, then the dampers start to close a bit and you start to reheat, like the heating coil to turn on. And the cool part is all these boxes act independently, right? And the main air handler, this big fan with a few Ds right now. So I'm assuming that most of you should be familiar with this. One of the first is ask the energy engineer to look if the supply fan have a VFDs on it or not. And but this the VFDs control. So, this is that the VFD really control based on static pressure, right? How much static pressure is required to push the air, and what we usually do is we set it to some point that down the stream, like a constant, to ensure that we satisfy the end of the VAV boxes at the end of the line. That concept might be older now, and with the computerized that we have now, have a different way to do that. But is static pressure, right? Static pressure is just a measure of pressure, and to make sure that we actually satisfy or we push certain CFM down to satisfy the VAV boxes. So the damper open up, increase the flow. When the damper close down, we decrease the flow, and that's how the VFDs reacting to it. But there's all these questions like, how much pressure enough? It's like, do you know, like whether it's, all this static set point, we not starving the box, how much loop that we need. Like typical right now is typical operation is like they update things 5 minutes, can better, So this is a problem with being set point of static pressure, right? A lot of time of buildings that I've been in they always like, we fix the static pressures to or 1.25 or something. But what if don't fix it? We make it as a reset or like a variable, and you can see that there is a lot of saving potential fan energy with this kind of like sequences. And the second part is, what is the right leaving air temperatures, right? So what is the air temperatures, like a supply air temperatures, what is supply air temperature for the air handler? It's a lot of time right now. I know that, I've been with HVAC for a while, and they just like 55 degree. And when I ask why, they typically don't know. After a while, like I learned that we need to go down to 55 based on humidity. You do the psych chart and you calculate the humidity. But right now with computerized system, we can actually ask like, what's the air temperatures needed right? We satisfy the humidity, but can we actually optimize what we send to the box? That, um, I mean, and again, this requirement outside air, right? What's the right temperatures needed? Like, do we need to add heat down there? And like, can we mix? Can we like absorb more heat from the cover or things like that? But what's the right air temperatures? So there's a curve and it shifts all the time, but um, and these are variable that we're looking at, right? And the standard industry standard right now is a turn response, right? Every 5 minutes they check. It's like, hey, I'm here, I'm there. What do you do? And this is based on latest ASHRAE guideline response, and but there's nothing saying that, hey, just make sure it's cold enough, you know, but nobody really what's cold enough mean. And some of you actually have implemented like before. So this is a ASHRAE guideline for high performance building six, high performance sequence is robust than the 5 minutes. Typical standard that I've been doing for a while. It's just say, hey, there's a point every 2 minutes, send requests, and the set points. Usually program this in the BAS and let them run. But will this solve the optimization problem? The other part of this trim and response sequence doesn't really tell you what's actually on down the line. Like some VAVs not PAVs damper might not respond. And hey, somebody put a coffee machine. It's like a coffee pot to my temperature sensor, spike up the heat, and that's why the dampers go up, and that's why the fans keep on running at high speed. And so smaller change, and and somebody's like, have you been in like a building and they say, whoa, it's too hot in here. They just set the set point down to 50 degree and basically create unstable to the on the HVAC system. Another part is like lately it's like, well, this computer in here. I mean, we have this problem right now in our office because of we start to all this 6 feet stuff weeks. We have an open office that we need to actually shove some stuff in to like a or one room that basically goes on because it's some of this computer like being shoved in and there's no air to that room. But I mean, these are just some problem with trim response. Our solution that we're trying to learn like right now is with computers and with cloud and things like that. Like, what if we can learn what's the optimum, like mice, like what's the optimum point or how of building to run at, learn it, and we can like if we have the data, the run thing, actually predict that at condition this is what kind of set point we need. So that's basically the whole of the dynamic VAV optimization by controlling the static pressure and the air temperature with the algorithm that we have, learning how the buildings behave before we can optimize how much air that we need to put in and what's the temperatures that we need to supply to the box. And again, it's like this environment that here are being that we that most of the time is because we can actually predict what the optimum temperature instead of you see trim and response, it's just plus minus 2. Like with the we predict based on outside air, it's like we need to set it to this point. So that's what the saving is. And some of the other things that we find that hey, we can actually get or solve some rogue zone, and we can detect like which V's that's not responding. So something like this, that the VAVs, like that's one VAVs that's like, hey, why is this, we keep sending this stuff, this is not supposed to behave this way. So instead of like maintenance trying to go in and do like one-off stuff, we kind of like, hey, go there. And I know that's why it's too hot to cold. There's some issue with this broken damper or something not take the valve or for like hot water is not opening up. And we tried it to in the several buildings right here with we have you know, first like we have Siemens office. The saving is low because like it's like around 8.4% because we did have some existing reset schedule, and we're pretty aggressive on that. And as you know, I mean, we are testing this stuff in our own office first of all. And we have like some commercial buildings, universities. On the average, without reset, we can achieve, like without existing reset, can achieve almost 30% of saving. And if you have reset, we can achieve those additional 10%. What I mean on reset is if the implemented the S-Ray guideline 6 for high performance. So if they have those implemented, we can save an extra 10%. Work. And this is actually the cool part of thing is don't really need to do anything internally. So it's all on the cloud. To do is put in this modem to push out the data to our server, and the algorithm and everything will be in the server. So it's more like a subscription model. And as long as we can feed and feedback and communicate, there's no programming because there's always the first thing that building owner asks is like how much time of programming that you need. And because if you to send technician travel, you need all this stuff and what kind of other control, like they always say that it's like how much to implement this, right? So I said, well, no, it's just a modem and with like and some connection, and if we have a secure connection to server, we're all good. And it's just saying that this is just a disclaimer, right? Because we haven't tested this in a critical environment. critical environment meaning like something like data center or like no operation room in the hospital. So we haven't tested this method in there. So that's why we don't think that, well, we're not sure that the strategy will work or not because we only have deployed it in like general areas. And but that's my presentation on the machine learning. But like as usual, like HVAC is all about priorities, right? So you can manipulate, you can do, you know, but what is your priorities? I mean, right now there's health, there's comfort, and there's efficiency, you know, and our job is to be able to balance all these three items to make sure that we operate the like the best way to operate for the building right now. And it's all, I mean, no building owner will say, like, hey, I'm satisfy all this and we make your place more comfortable and we will operate efficiently. Like they will not, we can do that. And there it goes. All my presentation, that's all I got. You have question, feel free to ask and bring it back to Seoul. And there's my contact right there.
Oh, thank you, Andrea. Well, I do apologize, everyone, for the quality of the internet. So I'm just getting my, maybe I should put my earphones on. So
yeah, I guess this thing come to a time. Maybe the fire actually affected my connection. So yeah.
Yes, and I didn't see any questions so far. Oh, what happens with do you? Okay, so we do have one question here. I'm just checking the chat box. Okay. Maybe we should give 20, 30 seconds to people to send us their questions.
Sure.
Just because, like I said, when we receive more than a few questions, and we do need to choose between those questions on which one to be sort of answered. But it seems like so far we only have one question. What happens with DVO when virus is detected in the building? Vasily is asking.
Oh, okay. Well, so like I presented there, I mean, there is what we call a defense mode. So when virus is detected, it will automatically or per, you know, an input, it will go to defense mode, which is will increase the temperature set point of the room. So instead of the, and the cool part is like instead of the VAVs trying to increase it, we can have the AHU to supply warmer air. And it will increase the temperatures of the building like 80, 85 degree to flush out, and also increase the outside air and run it for a few hours until it's until like the facility manager bypass it and call it safe. So but it's going to try to, like, it goes on the flush mode, make sure everything is safe.
Okay. I don't see any other questions, but I have a question myself. If
Sure.
I was wondering how long it would take to get the machine trained and get the results you want to get?
Well, that's a great question because that's something that we are we're a bit like, I mean, we question that when we first start the project, right?
Mm-hmm.
So like it's like how long will it take to get the building behave? So far that the answer is that may vary per building, but we try to hit the bin outside air temperatures data. So as long as we can hit all those temperatures within the bin and just see how the building operates and optimize it,
Mm-hmm.
and we can we can tag that is the optimized mode of the building, then it will go there. So once we have all that data and all that, it's like think a bucket of data, like optimized building, and they keep iterate um, the algorithm of the optimization, and each time they calculate, you know, the energy usage when um, it hit a certain like pressure and temperature and the VAV boxes point and all this, right? It's automatically calculate and output the saving. So I mean, us as energy engineer, it's like when we do like the bin data and stuff like that, we're assuming simple stuff. But with this machine learning, we can keep learning, but at least we need about 3 months of data before we kind of say like it's good enough to start. We start to see saving after 3 months, basically.
Mm-hmm.
But yeah, if you know, it's like, but the more it learns, the better it will be, right?
Mm-hmm. So that was, yeah, I was going to ask that right after. So it does get, the more you train, I guess the more, the better your savings.
The better it is, yeah.
So up to
So
a
it's like
certain point.
your Alexa.
Yes.
The more
Okay.
you train them, yeah, it's like you start to study your behavior, the building behavior, the occupant, and it's start to put things to, you know, start optimizing. And you know, the cool part of this is like building change tenant all the time, and you can just hit the reset button and start to learn the new tenant behavior.
Exactly.
Right.
Yeah.
So
That's good. Well, I don't want to take all the time for myself, but there are a
sure.
few more questions. Someone is asking about the estimated, well, Kevin's asking about the estimated cost per building.
Okay. I mean, the cost per building is varies depend on how much data or how much how many like VAVs and variable it is. And so the startup cost is about, I think it's like 5 to 10 grand US, just, you know, to set up the modem and to set up like the program and things like that. But
so this would be residential, correct?
no, this will be commercial.
Okay.
Right. So
okay, so not too bad then.
It's not there the setup costs, but there will be monthly costs and things like that. It's not too bad. So the goal is to have this deploy and its subscription, right? And then the more building it is, it's like a software as a service type of model. So I mean, yeah, it's like all the software subscription model that we have nowadays.
Okay, hope that answered your question, Calvin. Ron is asking, looks like the infection rate is very related to the air change rate. Does the smart ventilation have a epidemic mode to increase the fresh air?
Well, the air change rate, I mean, the infection rate, the air change rate in the inside a building environment, mostly driven by the code, right? It's like what's the outside air requirement, but the infection rate, I don't think um, not depend on how much ventilation of outside air in the building. It's more like how close you are with the infected patient, right? Like with the infected person. I shouldn't say patient, but if, and also like that's the other part is people, I think there's some misconception that we can just decide and we put a lot of air, the positive pressure. Those will actually push the virus around. So the more airflow,
Yeah,
the more all this particle around. So I mean, yeah, that's why I mean that's the misconception that a lot of building operators that's like we just flush everything and make it safe, but you actually make it worse.
So you could
So
possibly make it worse. Yeah.
yes, you could possibly make it worse if there's an infected person, right? It's like that's, but I mean, defend like, but to flush it, right? I mean, you do need the outside. You know, you need to flush it. That's how you use the outside air for. But that's we don't want to make our energy costs like. I mean, that's the thing. It's like with ASHRAE guideline nowadays, and with building operate with DCV, you always try to reduce the outside air because that's the most costly thing in the building. Like the treatment of outside air is the one that's driving the energy cost. So we're trying to not do that. Instead of putting all this other mitigation measure. And I mean, there's a lot of push with UV or bipolar, which I'm not quite sure if they're effective. I know UV is effective, but you need to get the UV system inside the AU. So by then the virus dried up, and if you have good filter, it's all gone. So yeah, but I mean, yeah, how that, well, it's a judgment call by building owner as far as I know. But I mean, there's different there's different tolerance. Like I mean, it's like based on owners and human, right? It's like people, you know. But outside there is like I'm trying like with this and the sequences. I'm more trying to push like how can we make sure it's safe enough that we don't, and also not using all this energy and skyrocketed the building operational costs, right? So
Daryl is asking if the system is taking into account better filters of products in their algorithms, or does it even matter because it's all about the static pressure in the end?
I mean, at the end, I mean, so your question, Daryl, is about ChemFill. Yeah, ChemFill, some ChemFill like filter, especially those carbon filter and stuff. They they're pretty bad. They require a higher static pressure to operate. But I mean, it doesn't really matter because it's learning the building, right? It's learning the building and it's learning what's the optimized sequence of the building. And like even like right now with the wildfire, it will look at the of the outdoor air and check, and it actually will predict that if your can fill, like if filters actually plug, because I know that we have several buildings right now that we need change filter, because you can tell the static pressure suddenly is like whoop, like up, just the wildfire and all the, you know, all the soot from the fire.
Mm-hmm.
Right?
Okay,
Any more
doesn't look
questions?
like there is any other questions. Do you want to touch base on the how does the security requirements work for the data that is uploaded on servers, Siemens servers? So do you have like agreements with the IT sort of client
Yeah.
representatives, or how does it work?
So that's what we will need to do is we quickly talk to the IT representative, and the IT will need to give us what are their protocol requirements for uploading the data. And the other part is we have like a disclosure. We are uploading a lot of all this building data, and I mean, some customer are sensitive to that, but some are not. So yeah, we need an agreement with the data.
That's
Our
where
connection, yeah, to the server, we upload things through a VPN, so it's pretty secure in uploading and, you know, to our server. And I mean, I think for this one we actually use either Microsoft or AWS server as the storage instead of our own, just because have more, they already out there and they kind of like a standard for security. You know, people will feel much better if we not start to like, I mean, if you start to say it's we store it in Microsoft data center or Amazon data center, like AWS, is kind of the standard of the industry. Yeah. But I mean, we don't own the data. That's the other part. Is like part of the agreement is we don't own the data. We own the algorithm. And if the customer decide to like cut the contract or whatever to the subscription, it's just going to go away. The data is just going to be deleted.
But you already make use out of that data and make the algorithms and use it.
Right. Well, the algorithm is learning. We already have the primary algorithm to learn, but the hardest part is even we use the data, we we cannot reuse it to different building.
Yeah.
We just but the thing is like that. It's like you said, it's like right. We have the data and we keep learning, and once we learn more, we more like we keep improving, right? So
and then you create
we use that. Yeah.
Okay.
Then you create this matrix, right?
Okay, we have only 1 more minute. Okay, I was wondering if it is another question. So thank you so much, everybody, first for attending and for giving your time, and of course, Andreas, thanks for the presentation. It was really informational and useful. If, like I said, we will be sending the PDF of the presentation to the attendees, and let us know. I do apologize again for the connection. I don't know if you guys how you felt about it, but again, you can write back to us, and we can't do in-person meetings anymore for another while, so this is better than nothing. So we're doing our best, and thank you so much, Andreas, again. Hope everybody have a great day.
Thank you, Sol, for the opportunity, and I apologize again for this thing. Like I'm not quite sure why my on off, and apologize for that.
Thank you. Have a great day, everyone.